Welcome to level 1.3, and we are going to talk about everything you need to know about lines. So this should be the thing that you've seen 3 different times. Only the first time in Algebra 1 you saw it for like a month and a half. And the second time in college algebra last year you saw this for maybe a couple of weeks, maybe a week or two, and this time we're seeing it in a day. Most of this you should know. So first let's start off with the basics. Slope. When you've seen slope before, it's the rise of a line over the run. It's the y's over the 1. It's the change in y over the change in x, which if we want to write that out, if we're given 2 points, it's the difference in the y's over the difference in the x's. So just like the distance formula, we have the delta. Remember, here's our delta. Let's just draw that in red. Make that stand out a little more. We also call slope the average rate of change. And that's the phrase you'll see again and again and again once you get to calculus. So just as we see over in our picture over here, if we have a line, we look at the 2 points, we have their ordered pairs. To find the slope, you take the difference in the rise, or the y's, and then the difference in the runs. It's the change in y. I'm going to write it again. Change in y over change in x. Super, super important. So a couple quick questions. What's the slope of a vertical line? Well, let's just draw that picture quickly. Let's do a different color. If we look at a vertical line, which I did a great job of drawing that in, well, the change in y is some number, but the change in x is 0. So just like trying to walk up a wall, we say the slope of a vertical line is undefined. Likewise, we can look at what's the slope of a horizontal line. So given any horizontal line, what's the slope? Well, the slope of a horizontal line is 0, or m equals 0. And why is that? Well, just like on a floor, if it's flat, just like a horizontal line, it has 0 incline, it has 0 slope. So other terms that you might be asked is, what does positive slope represent? Well, positive slope, so if we have positive slope, SL, that's right, positive slope, we have an increasing line. And by what I mean by increasing means we're going up. If I have negative slope, that means I have a decreasing line, or we're going downhill, we're going down. So, based off of this, let's try a couple of these out. Find the slope of the line that passes through the points 1, 2, 5, 3. So, to find slope, if you've forgotten this formula, I'd write it the first couple times just so you don't make any mistakes. Difference in the y's over the difference in the x's. So it's negative 3 minus 2 over 5 minus 1. Negative 3 minus 2 is negative 5. 5 minus 1 is 4. So our slope is negative 5/4, which means we go down and right. Down 5, right 4. All right. So, example 2. Draw a graph of the line that contains 3, 2. So, take our pen, 1, 2, 3, up 2. There's our point. And has a slope of 3/4. So, the first one is going to be up, rise, up 3, 2, 3, and to the right 4. So if I go up 1, 2, let's see, my point's here. Good. 1, 2, 3, and then I'm going to go run 4. 1, 2, 3, 4. 1, 2, 3, 4. So I'm going to put my new point and draw my line that connects those two. If I have a slope of negative 4/5, I'm going to draw my xy coordinate plane. I'm going to plot my point 3, 2. So 1, 2, 3, 1, 2. There's my original point. And a slope of negative 4/5 is we're going to go down 4. So down 4, right 5. So down 4. 1, 2, 3, 4. Then right 5. 1, 2, 3, 4, 5. And there's our new second point that passes through the point that has that slope. Now, if you don't like going down and right, you could also go up and left. Just like here, instead of going up and right, you could go down and left. And because of the symmetry of a line, we can do that. So next up, graph the equation x equals 3. So this is a vertical line. All vertical lines are x equals some number. And why is that? Well, if I go over to 3, y can be anything, but x is always going to be 3. So no matter what number I plug in, 1/2, whatever, I'm just always going to be at x equals 3, which gives me a vertical line. Which means if I want a horizontal line, that means we're always going to have y equals a number. So for vertical, we have x equals. For horizontal, we have y equals. All right, so flipping the page, we're going to start off with a couple of different forms of our equations. So we're going to talk about point-slope form, we're going to have slope-intercept form, and we're going to have general forms for lines. So point-slope form. If you're given a point and a slope, use point-slope form. That is the simplest way I can say it. If you're given a point and you're given a slope, use point-slope form. Point-slope form is y minus y1 equals the slope times x minus x1, where your point is at x1, comma, y1. That's what that says right there. Just rewritten. So, let's try it out. Write the equation of the line with slope 4. I'm going to write this out. M equals 4, and containing the point 1, comma 2. All we're doing is plugging right in. So we have y minus the y value, which is 2, equals the slope, which is 4, x minus 1. That's it. We are done. Let's try it again. Write the equation of a horizontal line containing the point 3, 2. Well, as we looked back here, the slope of a horizontal line is 0. So we can assume that the slope is 0 and our point is 3, comma 2. So if I wanted to use point-slope form, we have y minus 2, which is our y value, equals 0 times x minus 3. Now what happens to the right side is all of that's just 0. And if I want it to be fancy, to match what we wrote on the front, if I add 2 to both sides, I just get y equals 2. That's why, if we want to write the equation of a horizontal line, it's just y equals the number. In this case, it's just 2. And if you know that, you don't have to do all of this work, and you can just jump to y equals 2, because that's the y value. Next up, slope-intercept form. If you are given a slope and the y-intercept, then use this. This, for the longest time, was the form that you had to type into a graphing calculator. And that's really the easiest definition for why this exists over these other three forms. It's the most commonly used one. It's the one you've seen since Algebra 1. And it's the one you guys should be most familiar with. So, slope-intercept form is mx plus b. M is the slope. B is the y-intercept. So, let's look at the next one. Find the slope and the y-intercept of the equation 2x plus 4y equals 8. And we want to graph the equation. All right. That's not in slope-intercept form. We want to get the y by itself. So, solve for y. So I'm going to subtract the 2x over, so I have 4y equals negative 2x plus 8. I'm going to divide everything by 4, so I get y equals negative 2/4 x plus 8 divided by 4 is 2. So the easiest way I can write this is y equals negative 1/2 x plus 2, which means my slope is negative 1/2. My y-intercept is 2. And if we're graphing this, I start at my y-intercept 1, 2, plot my point. And then I use my slope. I go down 1 to the right 2. And if I wanted to do it again, I go down 1 and right another 2. 3 points in general is the best number to predict a line. The last form that we're going to talk about is general form, which we just saw in the previous problem. General form, we have ax plus by equals c. This is the easiest form, to find x and y intercepts. So we're going to look at that on the next page. So utilizing general form from the previous page, and I'm just going to write that at the top, ax plus by equals c. See? This problem is given to us in general form, and it's asking us to graph. And as I said before, the easiest way to graph is we need at least 2 points to graph. But that's not, we can have more. The lowest number I'm going to ask you guys for is 2 points. So, how do we do that? We could put it in slope-intercept form. We could put it in point-slope form if we really, really wanted to. What I'm going to suggest is find the x-intercept, find the y-intercept. How do you do that? Well, the x-intercept is, if I cover up the y value, I'm left with 3x equals 12. That's plugging in 0 for y. Hopefully we can all solve this. We get x equals 4, which means our x-intercept is at 4, 0. Likewise, if I cover up the x, plug in 0 for x, I have 6y equals 12. Now, I can solve that super easy, and I'm just going to write that. 6y equals 12. Divide both sides by 6, I get y equals 2, or another way of writing that is 0, 2. That gives me my 2 points, and I can graph this. So I go over to 4, 1, 2, 3, 4. That's on my x-axis. I go up 2. That's on my y-axis. Connect the dots. My favorite form is general form because I can easily solve almost any of those equations. So that gives us our 3 forms. That gives us point-slope form, that gives us slope-intercept form, and then the last one is general form. Next up with lines. We're going to talk about parallel lines, perpendicular lines. For 2 things to be parallel, that means they do not touch. So, for 2 things to be parallel, what needs to be true? Well, 2 non-vertical lines are parallel if and only if, magical words we've seen since geometry, if and only if, they're slopes. I'm going to write that in red. They are slopes. are equal and they have different y-intercepts. That's for parallel lines. Same slopes, slopes are equal, different y-intercepts. Likewise, the criteria for something to be perpendicular is two non-vertical lines are perpendicular if and only if the product of their slopes is -1. Now what you guys have probably seen before is this means that their slopes are opposite reciprocals. So just as a quick aside, if I'm looking at 2, the opposite reciprocal is -1/2. What you guys might have heard to get opposite reciprocals is flip it and make it negative. Flip. Not flip the guy and multiply. Flip the guy, make it opposite sign. Not always going to be negative. If I have -3/5, the opposite reciprocal is 5/3. Those are opposite reciprocals. So, just to go over this one more time. Parallel lines, slopes are equal, and they have different y-intercepts. Perpendicular lines are two non-vertical lines whose slopes product is -1, or their slopes are opposite reciprocals. So let's give these next two a shot. So example 8. Show that the lines given are parallel. So what do we need to show? We need to show that their slopes are equal and different y-intercepts. So the easiest way to do that, put them both in slope-intercept form. So I'm going to subtract 2x, so I get 3y equals -2x plus 6, and then I'm going to divide both sides by 3. So I get y equals -2/3 x plus 2. Likewise, I'm going to subtract 4x here, so I get 6y equals -4x. I'm going to divide both sides by 6, so I get y equals -4/6x. And I'm going to simplify that, which is -2/3 x. Here, I have slope of -2/3. Same thing over here. I have a slope of -2/3. My y-intercept here is 2. My y-intercept in the second one is 0. So if I've met the criteria that we set for above, the slopes are the same, and they have different y-intercepts, and so by definition, the two lines are parallel. So let's try the next one. All right, so for example 9, we're going to find the equation of a line that contains the point and is parallel to the line 2x plus y equals 6. So first, I want to know what the slope of the parallel line is. So if we remember our symbols, these two lines, it's not 11, it means parallel. Our parallel slope, well, here, if I subtract 2x to the other side, I get -2x plus 6. So right here is my slope that I want. So my parallel slope is -2. Now I have a point, 2, -3, and a slope. If I'm writing the equation of a line, I want to do what's easiest. So I'm going to use point-slope form. Okay? So point-slope form, y minus a -3 equals the slope times x minus 2. Just to simplify this, so that's y plus 3, because when we subtract a negative, the same thing as adding. -2, x minus 2. That's all we have to do. It asks for the equation of a line. It doesn't specify what form, so point-slope form is just as valid. We got 2 more questions, and then we're done with level 1-3. And we're almost done with the chapter. All right, example 10. If a line has a slope of 3/2, write the equation of a line that is perpendicular that passes through -1, 1. Okay, so our original slope is 3/2. In order for me to find out the perpendicular slope, and just as an aside, again, perpendicular, this is what the symbol is, means perpendicular. So, in order to figure out the perpendicular slope, I want to find the opposite reciprocal. So the opposite reciprocal, if you will. So we're going to flip this fraction. So instead of 3/2, I have 2/3, and the opposite, so I make it negative. So there's my perpendicular slope, and here's my line, my point, -1, 1. So again, I'm going to do point slope form. So y minus the y value equals our slope, -2/3, times x minus the x value. Subtracting a negative becomes a positive. There is the equation of our line that passes through our point that is perpendicular to our other line. Last up, example 11. Find the equation of a line that contains 1, -2 and is perpendicular to the line x plus 3y equals 6, and then graph the 2 lines. Okay, so we have a couple things to do. I'm going to grab a different pen. First off, I'm going to get our original equation in slope-intercept form. 3y equals -x plus 6. Then I'm going to divide by 3. So y equals -1/3 x. 6 divided by 3 is 2. Okay, so in green, my perpendicular slope, I want the opposite reciprocal of -1/3. So the opposite reciprocal is, instead of 1/3, it's going to be 3, and then I'm going to make it opposite. So my slope is going to be +3. And just as an emphasis, +3. And the point that I want this to pass through is 1, -2. So the equation of my line for my perpendicular one in green here is going to be y minus -2 equals 3 times x minus 1. That's my equation. Here are my 2 different equations, and now I'm going to graph them. So let's draw my xy coordinate plane here. And I'm going to start with my first equation. The y-intercept is 2, 1, 2. Plot my point. And I'm going to do this in blue so everything color codes and matches. So y-intercept's at 2. Then my slope is -1/3, so down 1 to the right 3. 1, 2, 3. And knowing that I can kind of draw a straight line, there is my blue equation. Likewise, 1, -2 for my second line. I have a point, I have a slope. That's what I'm going to graph. So I go 1, -2, put my point in there. My slope is 3, so I go up 3. 1, 2, 3, to the right 1, right there. And I'm going to draw in my line. And because my slopes are opposite reciprocals, these 2 lines, by definition, are perpendicular. So that takes us through level 1.3. I have a list of all the problems at the bottom, and then a couple challenge problems for you guys to work on in class. One more section to go.